Solving quadratics using square roots. Last time we talked about how x-intercepts are called solutions. Well, did you know they're also called zeros and roots? We're going to see a little bit more today why they're called roots. First, let's start off by reviewing simplifying square roots. So we have a whole myriad of perfect squares that we can take square roots of. So here are some listed. But if I don't have a perfect square, then I want to make sure that I'm simplifying the radical. So like this first example here, square root of 72. Well, let's think of some numbers that multiply to 72, where one might be a perfect square. And it's set up for us. So we have square root of something times 2 is 72. Well, 36 times 2 is 72. So the square root of 36 times 2 is the square root of 72. Well, what's the square root of 36? That's just 6. So I can rewrite this as 6 square root 2, because the 2's just left behind. Let's try it again, square root of 20. See if you can rewrite it with a perfect square. Did you get what I got? Square root of 20 can be split into square root of 4 times square root of 5. So that square root of 4 is just 2, so 2 root 5. And then square root of 125 is really the square root of 25 times 5, so 5 root 5.
Now we're ready to solve by square roots. When do we use this? When there's an x squared term but not an x term. Then it's easy to isolate that x squared. Keep it positive when possible, and then we're going to use square roots to undo the square. Let's look at our example. It has 0 equals x squared minus 16. Keep in mind I want to keep the x squared positive if possible, so I'll actually add the 16 over and then rearrange it so x is in front. So then I have x squared equals 16. Let's square root, because a square root will undo a square. At that point, what happens? Square root of x squared is just x, but careful, because when I square root the 16, I actually end up with two possibilities. So you'll see that it says x equals positive or negative 4. Think about why that's true. So the idea is, if I square 4, I'll get positive 16. If I square negative 4 times negative 4 is also positive 16. So both of them work in my original equation. Let's go ahead and solve for x squared. Once I have x squared isolated, then I will square root both sides. You absolutely must remember when you square root both sides, you have two possibilities. X equals positive and negative 3. You can always go back, check it in the original equation to make sure they both work. Okay, get as far as you can on number 2 and number 3, and then come back and check in with Miss Ryan.
Now remember what Mrs. Peart said. Do not square root at this step. You have to isolate the x squared first. So get rid of that 7, then you can square root. Let's check your work. For number 2, I got x equals plus or minus square root 5. Now square root 5 is not a perfect square, and I can't do any simplifying there, so I just need to leave it exact. Plus or minus square root 5. Now number 3, holy moly, after I divided that 9 off, I had 35 divided by 9, so then when I square rooted both sides, well, if you have a fraction, you just square root the numerator and you square root the denominator. So I had x equals plus or minus square root of 35, there's no perfect squares in there, I can't do any simplifying, divided by, well, square root of 9 is 3, so plus or minus square root of 35 divided by 3.
One step further now, let's take a binomial squared and then square root it. Well then, of course, the square and the square root undo each other. So in this example, highlighted in pink, we end up with just x minus 15. Okay, look at number 4. Same idea. We're going to go ahead and square root both sides. But remember, when we square root, what ends up happening? Positive, negative. So we end up with x minus 2 equals positive or negative 5. Then what? We don't have it solved for x yet, so I want you to be very careful here. Let's split this into two possibilities. X minus 2 equals negative 5. X minus 2 equals positive 5. Don't skip this step. Solve. So we have our two possibilities. X can be -3 or X can be 7. Now let's try and really understand why that works. Let's go back to our original equation. X minus 2. So I'm going to plug in the -3 for X minus 2. Quantity squared, well, that's -3 minus 2 is -5. Squared is positive 25. Yay! Then the next one, we have 7 minus 2 is 5. 5 squared is 25. Yes! Do you see how this works? So number 5 has a couple more steps, but it pretty much works the same as number 4.
Wait, be careful here.
So let's make sure that we point out this. No bueno! No, you cannot do that! Stop! Turn away! Remember, it's being squared. You cannot simply multiply that 4 in there. Undo, undo. If we're not allowed to do that, what are we allowed to do? Well, let's divide the 4 out. Will this work in our equation? Yes, yes it will. Let's take a look at our next one. I want you to do the first couple of steps. Okay, I'm gonna pause here. I hope you tuned in for a moment. Square root of 8. Square root of 8 is not a simplified radical. 8 is 4 times 2. So square root of 4 is 2. It comes out, and then there's a 2 that stays in. It's always helpful to do a little bit of a side note if you're afraid that you're going to make a teeny bit of a mistake. So let's take a look. So there we go. X plus 1 equals positive negative 2 root 2. And then what? We end up with 2 equations from here. Okay, a lot of stuff went on here, and I don't want there to be any misconceptions. When we subtracted that 1, you're not allowed to subtract it from the 2 root 2 because those are not like terms. So just keep it out in front. Typically, we'll write the integer in front of the radical, so just get used to doing that. Also, we could write it combined, but we want to make sure that you understand there are 2 solutions. So I could have at the top, we write it as x equals -1 plus or minus 2 root 2. It's totally fine to write it in this manner, but we have to remember that this means there are 2 solutions.
Wow, this solving by square root stuff is kind of radical. Okay, you've got this next one. You're trying to isolate that binomial that's being squared, so take a moment, get that isolated, and we'll check back in. Wow, this time both the numerator and the denominator are perfect squares. The square root of 25 is 5, square root of 4 is 2. So I have a positive negative 5 divided by 2. Great, so now let's set up our 2 equations. To finish isolating x, I would divide by 2, but we don't want 1/2 divided by 2. Yuck! So we're gonna multiply by the reciprocal instead.
Remember inverse property of multiplication?
Can you hear Mrs. Peart over there? Okay, x equals 11/4 for that one. Go ahead and try the next one on your own. Oh, did you see that? -9 divided by -16. Thank goodness they were both negative, right? Because when we divide or multiply 2 negatives, we simplify to a positive. Whew. So that way when I start square rooting, I'm square rooting a positive because we don't know yet how to square root a negative. Did you get x equals -23/4 and x equals -17/4? Really be careful, right? After I square rooted that fraction, I square rooted the numerator and denominator, then I split into my 2 equations and solved carefully, using that side note to help me add and subtract those fractions. Okay, last one, test yourself. You can do this. look at the first solution. I got x equals 14/5. Now be really careful at all the stuff that happened there, right? So I took my equation, I subtracted my 7, did a side note so that I could add to that fraction, and then multiplied by the reciprocal of -3. So -1/3 on both sides. So I'll stick with you on this next one just in case some of those steps were a little confusing. So the first thing I'm going to do here is subtract that 7, so -3x equals. My side note over here, 7/5 minus, well 7, I want it to have a denominator of 5, so I'm going to multiply it real quick by 5/5, so then I'm going to have -35/5. 7 minus 35, -18/5, and then I want to divide by that -3, but then I'm going to have a fraction divided by something, and that's going to get messy. So I'm going to multiply by the reciprocal of -3. Since 3 goes into 18, I can change my -18 to -6 after dividing by the 3. Feel free to pause here and really make sure you understand those steps. Solving by square roots.